Let me show you how to be a good Bayesian. Change your predictions after taking information in.
I'm wondering if there are some common misconceptions you've seen about quantum physics, maybe even about patient stats, that you often encounter, and how do you usually address them?
I wrote an entire book not for children. You may have to edit this part out because the book's called Quantum Bullshit. I don't know if that's allowed in the podcast.
That's all good. Yeah. I'm French, so we have no worries with swear words.
That's the title of the book. The subtitle is, it's kind of science comedy. So the subtitle is How to Ruin Your Life with Advice from Quantum Physics. And it kind of goes through a lot of the common misconceptions and how each of these major concepts in quantum physics are misused. Things like superposition, entanglement, quantum energy, quantum uncertainty, these sorts of things, how they typically are misused, and what's the most sensible kind of way to understand them without having the mathematical background that underpins the framework of the theory. So yeah, there's lots of them. And if you want the comprehensive list, definitely check out the book. I'll give you a typical example is the idea that superposition means things can be in two places at once. And that just saying it out loud should make it clear that that's a logical contradiction, because, it's a dichotomy between, true and false, and you can't have something that's both true and false. So sort of a logical contradiction. But that being said, physicists will still say things that sound kind of like that. So an example might be this famous double slit experiment where you have some sort of screen, it has two holes in it, and you fire electrons at it, and you see an interference pattern on the other side instead of just two dots where the electrons landed, suggesting that the particles interfere with each other. And if you do it one particle at a time, that means it had to interfere with itself, which means it had to have gone through both slits at the same time. So the electron or whatever particle it is, had to be in both of those places at the same time. But we always run into these problems when we try to explain what's going on in quantum physics by analogy to our everyday world. It's a different world that we don't have access to. We don't have a language and a familiarity with. So we have to use these analogies, but they very quickly break down. So that's absolutely not what's happening. And things can't be in two places at once. And you shouldn't buy a quantum crystal or something because it promises that that it can do that.
Sure.
And for the Bayesian, I find actually, so when you can kind of explain to people, the way I do it now is to walk through that idea that in quantum physics we have these concepts and we have to use a language that we're familiar with, but that language isn't really suited for trying to do anything beyond explain that one special thing. You can't extrapolate using those analogies because you'll quickly fall prey to misconceptions. So that's typically how I explain it in the context of quantum physics. And quantum physics is actually quite popular in the popular culture. I don't find that Bayesian probability is so popular in popular culture. So, the word quantum crops up all the time attached to things. Nobody's selling Bayesian healing crystals. So these aren't popular. Oh, that's actually not a bad idea. You don't need to approach it the same way because you're not typically talking to a lay audience when you're talking about misconceptions and Bayesian probability. Usually it's someone technically minded who knows something about some technical topic that the probability is being applied to, or probability itself. And in physics, the main problem that people have, you could call it a misconception, is that Bayesian methods are subjective, whereas frequentist methods are objective. And as a scientist, you need to strive for objectivity. So that means that you shouldn't use Bayesian methods and you have to use frequentist methods. But the easy thing to point out is what you could do is just have them walk through how they would apply frequentist methods and then point out that they had options, and then they made their subjective judgments on which options they were going to choose to solve their problem. So it's no less subjective. And in some sense, it's worse in the sense that you're not being honest about the biases that are going into what you're doing. So yes, Bayesian methods are absolutely subjective, but they're subjective in the most honest way possible.
Yeah, that's usually the way I go about it also. The faster you're gonna abandon the idea that there is an objective way of seeing reality, at least the way we are made, if you're a Homo sapiens, the faster you'll be able to think about real ways to actually trying to understand what's going on. And so, yeah, it's usually the way I go about it. But yeah, I mean, these are fascinating topics. We've actually covered some of them in some of the episodes we've already done on the show. So one before you was episode 97 with Alan Downey, where he actually talked about that, where he was like, he has also a blog post about it, comparing this idea that Bayesian results converge to the frequentist results to the limit. And so that was interesting to talk about it with him, because he actually argues that it's never the same. And that's not a problem. You should still choose the Bayesian framework, actually. But that was interesting. So you have that for people interested. And also I'll put in the show notes. So I'll put that one, and I'll put in the show notes episode 50 and 51. 50 was with Aubrey Clayton, who wrote an amazing book called Bernoulli's Fallacy and the Crisis of Modern Science. So that's more about the history of statistics and how and why frequentist statistics came to dominate the scientific world. So much more epistemological, very, very fascinating book. And episode 51 was with only Sir we've had on the podcast, I think, Sir David Spiegelhalter, about risk communication, how to talk about risk, especially to a lay audience and people who are not educated in stats or in the scientific method. That was way closer to the COVID pandemic. So that was very interesting to talk about that with him, because these topics were absolutely important in time of pandemic or very stressful situations, right? Who would think so, right? That the nerds actually had tried all along to talk about stats and probabilities. This can save you during a pandemic. But yeah, this is also something that I think must be added in these discussions. Like, often it's not really in the papers that you see these misconceptions, but it's more in the way the papers are interpreted by people who are not equipped to read the papers. And so I think there is a job in the world that needs to be filled, which is basically making the bridge between scientific papers and then what ends up in the papers, in the newspapers. And that is a bridge that still has to be built. And we're trying to do that in a way with our work, but it's just like, it's still so much things to do still. And most of the time, sometimes my game is really to do that. It's try and see what people are talking about on Instagram or stuff like that, and then actually try and go to the source that they are supposed to quote, to cite. And then you see that basically it's just like the first person who reported on the paper did understand the paper or just read the abstract and the title. And then just everybody cite that first source. So basically the first error is just like trickled down. And that's just fascinating.
Yeah, I think the solution has to sort of include actually that we'll write fewer papers. There's over 1 million academic journal articles published every year, and that's more than we can read, right? So there's the perverse incentives in academia now that kind of force you to do this, which means also that like most of those papers shouldn't have been written and didn't need to be written. I think it would be better if we had a more careful approach where the result is fewer papers that are better written.
Couldn't agree more. And also it's something we've talked about on the podcast several times. Incentives in academia is hard to change, but needs to be changed. But yeah, hopefully that will. And having people like you in academia definitely helps. And well, hopefully with time it's going to evolve. But yeah.
Let me show you how to be a good Bayesian. Change your predictions after taking information in.